to the first virtual Science Under the Dome talk. My name is Jimmy Negus, and I'm a fourth year graduate student at CU Boulder's Astrophysical and Planetary Sciences Department. On behalf of the Science Under the Dome admin team, welcome. Throughout the pandemic, we will continue providing high-quality videos under the following categories: science and society, the science of sci-fi, and climate change in our backyard. For CU students, you can learn more about us on CU's Buff Connect site or shoot us an email at scienceunderthedome@colorado.edu. Also, if you have any questions throughout the talk today, please feel free to add them in the chat box and we will get to them during our Q&A session. So today's talk is going to be provided by Will Holsclaw. Will is a second-year PhD student in the history department. His research focuses on the role of space exploration and militarization on foreign policy, both in the US and around the globe. He is a lifelong space nerd, a planetarium buff, and also a graduate of CU's Space Miner program. We will also be joined by our navigator today, John Schiller. So today we will be discussing science and society. Our Earth is a blue marble shining in the sun's light, but that's only half the story. The Earth's dark side, the black marble, tells the story of human movements, conflicts, our impact on the environment, and even the dynamics of the global pandemic. New satellites and spectacular astronaut photography have revolutionized what we can see in our planet's shadow. We will explore these latest images to discover the data they reveal and the tales they tell. With that, Will, please take it away.
Thank you, Jimmy, and thank you, John, our intrepid navigator here. Unfortunately, we're not able to be in the great Fisk Planetarium Dome and immerse ourselves in the visuals that we can experience there. But we're lucky that John has created a really excellent simulation that sort of emulates what the dome can do. And he's even recreated a moment from late December 1968. And the reason we chose this is a replication of the view that the astronauts of Apollo 8 experienced on Christmas Eve in 1968, when they were the first human beings ever to leave low Earth orbit and venture beyond the Earth's sphere of gravity. And as a benefit of this, as they were orbiting around the moon, they, rather surprisingly to themselves, they were taking pictures and they sort of discovered this view of the Earth from a long distance. And up to this point, no astronaut had actually seen the Earth from far enough away to see it as a full disk. And so this is something that kind of took the astronauts by surprise. And when they saw the Earth rising over the moon's surface, as you can see right now, it really kind of astonished them. And they hastily took some color film and tried to capture the moment. And as it has been said, when NASA astronauts left for the moon, what they really discovered was the Earth. And in the process, they captured an image that has become very iconic, and that's the Earthrise. And the commander of this mission, upon returning to the Earth, Frank Borman, really was encouraged to reflect on this. And when he reflected on this, he said, "The view of the Earth from the moon fascinated me. A small disk 240,000 miles away. It was hard to think that that little thing held so many problems, so many frustrations. Raging nationalistic interests, famines, wars, pestilence don't show from that distance." And this has become a very popular image of the blue marble that we have, and that we sort of pull back far enough from our Earth and we can sort of erase all of the problems that we see on the Earth, and also kind of humble ourselves and put those problems in perspective and show how petty a lot of them are. A few years later, in 1972, almost exactly 4 years later, another equally iconic image was taken by the astronauts of Apollo 17. And this was actually taken in early December 1972. And this was the last mission ever flown on the Apollo program. And this is the last time humans ever were far enough away with their own eyes to see the Earth from a distance. And this has become immortalized as the blue marble. And this image as the blue marble has actually been taken to be kind of a shorthand to describe our planet, either the blue marble or the pale blue dot, as we've seen from other images taken from a long distance. But this is such a famous image that I think it's easy to lose track of the fact that it actually shows real things that were impacting human society at the time. And I'll specifically draw attention to an area up in the top right. And in early December of 1972, as part of the typhoon season, there was the Tamil Nadu cyclone that hit India. And as a result of this cyclone, over 80 people were killed and 150 cattle. So this is a moment that is remembered in human memory, at least in one part of the world, that is actually visible on this image. And you can see these weather patterns from space in an image that many of us, and many of you probably have seen many times throughout your entire life. And it's this sort of image and like sort of critical analysis of an image from space that I want to talk about. But I'm not going to be talking about the blue marble today. We're going to be talking about the black marble. And this image that I show here kind of as kind of the reverse image of the Earth from space. This is not actually a photograph because no such photograph has ever really been able to be taken at this point. Low light photography just isn't very good. So anytime you see an image like this, it's actually a mosaic of images taken from satellites. And the specific satellite that takes most of these images is the Suomi NPP, which was launched in 2012. And it's operated by the National Oceanic and Atmospheric Administration, NOAA. And since 2012, it's been orbiting in a polar orbit, which means it sees the entire Earth's surface periodically. And every day or two, it actually takes a picture of most places on the planet at night, which is unusual because usually these satellites are solar powered and they just don't want to operate at night when there's no light. But this one actually has enough battery that it can take pictures periodically every night. And we can actually see change over time, which is one of the great benefits that this satellite has. And these three images you see here are kind of a selection, a sampling of the type of data that this satellite gets. On the left, you can see here the Nile Delta in Egypt, which is certainly a gorgeous site where so many of the people that live in Egypt, basically almost everybody in Egypt lives along the Nile River. Since ancient times, that's where the entire population lives. And it's very urbanized there and it's very bright. Another area that's been urbanizing rapidly is India in the central image. And on the right, it might not be readily recognizable, but that's actually the northeastern United States and up into Canada. And in the top, you actually see another source of light, which is the Aurora Borealis. And this here, you might, if you've ever seen the Aurora Borealis or pictures of it, you might notice that this is a little bit colorless. And this shows the kind of disadvantage that the Suomi satellite has. It only records intensity of light. It does not show any color. And this is something that is both a strength and a weakness of the satellite. So it shows the intensity over time, changing every time it takes a picture of a spot on the Earth, but it doesn't really show any of the color that you might see if you were looking at it from space. But we do have people looking at it from space. Oh, and this image here is just sort of a mosaic of the entire Earth, sort of laid out in a projection from this data, showing that it is not a photo taken from Earth like the blue marble, but a mosaic of many photos. But there are astronauts up in space that do take pictures in color, and they're on the International Space Station. And this is a sort of a time lapse showing just how vibrant these images are. And we have these courtesy of a rather everyday object, a DSLR camera, the Nikon D4, I believe is their favorite camera. And they have these great telephoto lenses. And with the great cupola that they're able to open up and look out, they've been able to really capture some spectacular images. And this is the other major source of imagery that we have today that's really been revolutionizing our view of the black marble. Here's another image of the Nile Delta taken from the ISS. You can see it's a much more colorful image, still mostly whites and yellows in the cities, but also you can see the blue from moonlight in the clouds, a little bit of flash of lightning off in the distance over Iraq, I believe, northern Iraq. You can also see some beautiful images of the Milky Way along with the that's the Progress module attached to the ISS and some sky glow from Earth. And sometimes they get artistic with it. This is a picture taken by astronaut Christina Koch last year. And she captured the stars swirling in star tracks. You can see some lights from cities swirling below, as well as lightning flashes all over the place. And one of the great advantages that astronauts have when they take these images is that they can capture moments in time that they can sort of just spot when they're looking. Here you can see some beautiful auroras on the horizon, and you can see a big city, which happens to be Edmonton in Canada. But you also see some little streaks of light here and there, and those are actually meteors happening in a meteor shower. I believe this was taken in August of last year, so this is probably the Perseid meteor shower. Another image she took in September of last year when she was orbiting is this image of the New York City and its 5 boroughs. I'm going to zoom in a little bit here before we talk too much about this. This is actually arranged with north being kind of down to the left and south being up and to the right. And you might notice at the southern tip of Manhattan, if you recognize it there, there's kind of a blue streak of light coming up right there in that circle there. And this is a image that you can really see what is revealed by the color. And some of you may have already guessed what this image is, taken in September. She happened to take it on September 11th when in lower Manhattan, they light up the Tribute in Light, which is a memorial to the Twin Towers. And this is what you would call in remote sensing the ground truth. If you look down at something from a long distance, you might not identify what it is until you get on the ground and see what it is. And so this kind of illustrates what the sort of qualitative experience you can get on the ISS that you don't get with the quantitative data, where it's just quantities of light being recorded by the SWOMI NPP. So it's this sort of dichotomy between quantitative data and the uses of that from the SWOMI satellite versus the qualitative color and sort of moments in time that we get from the ISS images. So one of the things that Frank Borman talked about when he came back from Apollo 8 was that you can't see raging nationalistic interests from Earth. And this has become such a popular thing to talk about that this meme came out several years ago. I'm not sure exactly who created it, but I can tell you 3 issues I have with it. First off, they don't seem very consistent about how they capitalize words, which frustrates me. Second, this image of the Earth is not actually a blue marble photo. It is actually produced by NASA, I believe in 2002, but it is also a mosaic of imagery, which is a bit of a disappointment because there are beautiful images, both from the Apollo era, as well as other satellites that exist today, of the entire Earth as a blue marble. So I don't see any need for a, if you will, a fake photo of the Earth to illustrate this point. And my third issue with it is that if you look closely enough, and especially on the black marble side, it's not true. You can see borders from space. Many of you who have looked at images of the black marble might be familiar with this area of the world. This is in Eastern Asia. And here you can see what appears to be sort of an island in the ocean. If I tell you that most of what you see on the left part of this image, all those lights, that's China, but you might think this is some sort of island, perhaps Taiwan off the coast of China. But in fact, that's South Korea. And the dark area between China and South Korea, that's North Korea. And you can see a sort of a dim glow in the center there, which is the city of Pyongyang, the capital of North Korea. And this sort of highlights the dramatic disparity between these two neighboring countries, which share many of the same history and culture, but for the last several decades have been divided. And one of the things that's really especially striking, if I look at it in the SWOMI data, I'll highlight here with the borders so you can see the kind of align yourself. Seoul is the largest city in South Korea, and that's the brightest spot there on the border, near the border. But also in both of these images, you can see a very fine, bright line dividing the two. You can see the sort of almost, if you thought of it as an island, you'd think those are beachside communities between South Korea and China. But those are not beachside communities. It's something rather less hospitable. That's the Korean demilitarized zone. And this is one of the clearest places on Earth where we can see a border from space. It's popularly said that the Great Wall of China is visible from space. That's not entirely true. In fact, there are many things astronauts can see from space. But one of the most dramatic is actually modern borders lit up from orbit. And here you can see that they light up the bulk of the border between the two countries, which is one of the most contested and tense borders in the world today. And before we leave Korea to other parts of the world, I want to take a moment here to call your attention to some other features in this image from the SWOMI satellite of Korea. Off the coast on the southeast, and this is indeed off the coast, you might notice a lot of little dots. And I just want to leave a bookmark here in your head. Just remember those dots, and we'll come back to them later. But let's talk a little bit more about borders from space. This is another image elsewhere in Asia from the SWOMI satellite. And this is a line that I noticed when I was looking through SWOMI data, just browsing around several years ago. And I was really struck by this bright line moving through this dark blue zone. And I was immediately struck as like, is this another river like the Nile Delta? But this is actually the middle of the Thar Desert. And these bigger cities are Lahore and New Delhi. Those are the large cities where people actually live. This is not a river. There's no river that runs through there. And this is one area where seeing the image in color from the ISS really gives us sort of a qualitative, bit of an illumination, if you will, to understand what you're actually seeing here. Several images show this bright orange line, which corresponds with that same line I was showing a moment ago. Here's another image, which is very a little bit crisper, but you can see this bright orange, almost looks like a river of lava moving through the desert. And this is the border between India and Pakistan, another two countries that have a rather tense relationship, but share many cultural and historical commonalities. And if you go down to the ground truth, you see why this orange light is produced as it is. It's this bright sodium lighting lining about 800 miles of border between these two countries. And this is a color that you do not see in the SWOMI data, so it's a little bit puzzling, but if you see it from the ISS with just a regular DSLR camera, a pretty expensive one, you can really see the color and understand a little bit more about what's actually happening on the Earth below. And so this bright orange line sort of shows us the ground truth and the sort of qualitative reality of what's happening on the Earth. Now, before we conclude that this is an exception that proves the rule, there are in fact many borders that can be visible from space, even during the day. And this is a border that's very familiar to many of us. This here is the border between the United States and Canada. And during the day, you might notice, this is not visible as much at night, but during the day, you can see that there's a cut line all the way through the forests between the two countries. And it follows the border perfectly. And if you look at it from the ground, you see that across the entire length of the US-Canadian border, which is in fact the longest land border in the world, there's sort of this no-touching zone, as it's been called, where they've clear-cut the forest to sort of demarcate this border and make it clear. This is not a recent phenomenon. This was actually clear-cut back in the 19th century. So we didn't start the fire in this case. And here's another border. This is actually the border between Norway and Sweden, two countries that are very friendly with each other. But of course, this place looks like a great place to go snowmobiling. So let's return back to Korea. I sort of left a bookmark in your mind about these dots off the coast. Now that we've established that borders are visible from space, what about some of these other problems that Frank Borman did not see from the distance of 240,000 miles away? These dots look almost like swarms of insects floating around. On the top left, there's Korea, and the bottom right, that's the southern parts of Japan. And this is even brighter. It's almost like a real bright glare from these dots swarming around. This is down in the South China Sea. You can see Thailand on the left and Vietnam up in the upper right. That's Ho Chi Minh City. It's the brightest city visible here. But off the coast, all around it, you can see all these little dots. And this looks very puzzling. But when you look at it in color, it's even more striking because it's not just a little swarm of dots. They're bright green, and they really stand out from the bright yellow and white cities on the coasts. And this has been captured by many astronauts for several years now, and it's a dramatic image every time I see it. And scattered throughout the sea are these green lights. And many of us might look at these and say, perhaps this is some sort of bioluminescent algae or some other organism that produces light on its own. But in fact, they're fishing boats, specifically squid fishing boats. And this is a practice that's been going on in some form for hundreds of years, but it's really been revolutionized by the cheap availability of LED panels. Sometimes they do it with more kind of ad hoc methods. And the approach that they're taking here is that these light panels actually attract the squid. And having looked at this phenomena, it's rather striking to find out, if you look at all the research that's been done on the subject, it's not really well studied, and nobody really seems to understand exactly why the squid are attracted to these lights. They seem to congregate in the shadow underneath the boat, sort of being attracted to the light but then avoiding it. But nobody really understands enough about why the squid are attracted to these lights. Green light seems to work the best, perhaps because green light filters through and is visible to the visible spectrum that the squid can detect, but nobody really knows exactly why the squid do it, and yet it works, and it is done on a massive industrial scale. And this is sort of bearing out the fact that our species is, we're very cunning predators, and we come up with rather clever techniques for hunting, but we don't necessarily comprehend why it works or what the impact might be. And so we see these images from space of hundreds and thousands of these fishing boats, doing an enormous impact on the environment, possibly a very negative one, but we don't really understand what the impact is because we don't understand the phenomena that underpins it very well. And here you can actually even see, this was actually a tourist in Thailand took a picture. If you saw this image out of context, you might think it's like a night vision view of something happening on the horizon. Images like this were popular on news channels during the invasion of Iraq back in 2003. But this is actually just a regular color image of these green fishing boats off the coast of Thailand. So even if you're just on the beach in Thailand, you can see them quite clearly. But there are other lights that we can see that are not caused by cities and that also represent humans' economic activities. And they rather stand out even with the SWOMI data where you don't see the color. This is the Persian Gulf, and you can see a lot of sort of glare colors or glare lights where there's sort of these flashes of light that sort of stand out from the crisper lines of the cities. And this is actually the natural gas burnoff from oil rigs. And you can see it in color here. This is around Kuwait City. And you can see these whole lines of these oil rigs that have been lit ablaze to burn off natural gas. This was also done intentionally in 1991 when Saddam Hussein retreated from Kuwait. He intentionally lit all of the oil wells in Kuwait on fire. And this was also presumably visible from space, although nobody that I know of took a picture of it, apart from the smoke probably. Here in the Gulf of Mexico, closer to home, this is off the coast of Houston and New Orleans. You can see these other lights, and these are not fishing boats, but in fact, oil rigs off the coast burning off natural gas. Why do they do this? Well, to put it simply, they're there to drill for oil, and natural gas is a byproduct that they also collect. But natural gas is not as profitable for them to transport from the coast. So they don't, believing they won't be able to sell it as easily, and it's not worth the transport from offshore to inland. They just burn it off to get rid of it. And this is a major factor in climate change. Just a few days ago, in fact, the New York Times reported that secret recording had been made among petroleum executives where they discussed this problem and how it was sort of a bad look for them, even though they deny it's as big of a problem as it is. If you want to see further evidence of the impact this potentially has on the environment, this is an image of Alaska taken by the SWOMI NPP satellite. Most of the lights on this are small towns and cities. The three in the south are Juneau, Talkeetna, and Anchorage. But the brightest of all the lights that you see at night in Alaska is the Prudhoe Bay oil field up on the north coast. And just a few miles to the east is the Alaska National Wildlife Refuge. And there are continuing efforts by the present administration and previous ones to open up the Alaska National Wildlife Refuge for drilling. And here you can see that they're already encroaching right on the edge of it. And at night you can see it if you go down to the ground truth. The lights are very visible there, but the scale of it is certainly visible when you look at it on the SWOMI satellite. But of course, humans aren't the only causes of lights on the Earth, either with cities or borders or economic activity. The Earth gives off plenty of light on its own. Even if we were not here, the black marble would not be totally dark. The most obvious and most common occurrence is lightning. There are some beautiful and spectacular images of lightning taken from the ISS, especially in these sort of time-lapse videos that they've taken. One astronaut that I read described it as signals being flashed back and forth across the Earth by the lightning as though they were almost intelligently created. Another image that we've already seen a little bit of is the auroras. And in the SWOMI satellite images, you don't really see much color with those. But from the ISS, we get these spectacular images. The auroras actually are created by interactions between the Earth's magnetic field and solar radiation from the sun. And they extend actually quite a bit above what we normally consider the the thickness of the Earth's atmosphere. And the ISS actually orbits at an altitude that it would actually pass through them if it was closer to the poles. So it's a really dramatic sight. They almost seem to be skirting the edges of them. And this is the northern lights passing over the eastern United States. But there's also an equivalent southern lights, the aurora australis on the south coast. And here they are basically going right through them. Really spectacular. Of course, there's also volcanoes. They give off light. This is actually not lava you're seeing here. This is ignited sulfur, and it creates a really spectacular blue flame. I chose this picture just because I think it looks really awesome. There is a little bit of red lava visible here, but these are actually also visible from space, although rather less dramatically and much less frequently than lightning. This is the Ijen volcano complex in Indonesia on the island of Java. And of course, where there's volcanoes, there's fire, but fire also is created by lightning as well, and as by human activity. And wildfires are visible from space. You can see sort of these rings of fire near cities on the Earth. This is actually in Australia in this image. But of course, right now we're very much in the thick of a terrible wildfire season, especially in California. And the scale of it is really striking and dramatic. These are actually weeks old now, these images from the Suomi satellite. These were sort of compiled by NOAA. And unfortunately, we don't get the colors. You can't really distinguish the cities from the fires, but they're labeled here. And you can see the entire San Francisco Bay Area there is right on the cusp of these large rings of fire all over the place. And there's huge fires to the south, the east, and the north of the Bay Area, where the sky is literally turned orange during the day for people. And our own lights can be affected by nature. This is an image of the Caribbean Sea taken by Suomi. And you'll note that one of the brightest spots is actually the island of Puerto Rico, which is a US territory just east of Hispaniola there, towards the right side of the map. And normally it's one of the brightest sources of light at night in the Caribbean Sea. But just a couple years ago, there was a hurricane that hit, and this video compiled by Goddard Center at NASA sort of shows the impact that the hurricane had on the lights. And this is one of the most crucially useful ways that the Suomi data can be used, is to track disasters. And when a disaster hits, natural or otherwise, you can actually track human infrastructure impact by looking at just the electrical grid and whether or not it's recovering from a storm or a conflict or a migration. And here you can see the path is overlaid. And NASA did a really amazing study where they correlated the Suomi data, where they were able to track the intensity of light coming from the cities in the wake of the storm with efforts at recovery. And they were able to actually make more concrete plans about how they wanted to arrange resources. This was a huge, it's the worst storm impact on infrastructure on US soil in history to date. And this kind of data really allowed people to assess the impact and find ways of addressing this huge issue in ways that probably required more effort than just a few extra rolls of paper towels. Natural disasters, of course, are not the only thing that cause dimming of lights due to tragedy. This is the country of Syria between 2012 and 2016. And 2012 and 2016 were the first 2 years where the Suomi data was put into a mosaic where they were able to really get a full global coverage of the entire world in those 2 years. And often people look at those 2 years to see changes between them. So this is 2012 in Syria. This is 2016. And as many of you know, during those years and since then, there's been a just absolutely terrible civil war in Syria. And I'm going to rock between these two images here to sort of highlight some specific changes. This sort of darker stream up in the northern and eastern part of Syria, that's actually the Tigris and Euphrates River Valley, one of the great cradles of civilization, and it's been inhabited for many thousands of years by humans. And it's one of the places that was hardest hit by the Islamic State and the Syrian government led by Assad during the civil war. And you can see the impact of this conflict on the dimming of these lights. And I want to call specific attention to the city in the northwest. Some of you may have heard of it, a city called Aleppo. During the 2016 election, one of the presidential candidates could not actually identify Aleppo. Somebody asked him in an interview, and he said, "What's Aleppo?" And this is a demonstration of how the sort of quantitative data that we gather from the Suomi satellite can illustrate the scale of the impact that the Civil War had. And in fact, they measured the light and it is 91% dimmer between 2012 and 2016 in the city of Aleppo. I could go down and show a ground truth, but it would be pretty devastating, and we've all had a lot of devastation this year, so moving on. Of course, part of the devastation this year that we've experienced in that part of the world is an accidental explosion on the docks in Beirut, Lebanon. This is a normal satellite view. I don't actually have any black marble images to show of this, but it's really dramatic to show kind of how satellite data can be used to grapple with the impact of disasters. This was just a normal satellite view of Beirut in May of 2020. This is in August. And you can see almost the epicenter of this explosion right in the warehouse on the docks there. Really striking and staggering images that kind of show the before and after. And this is one of the great tools that we can use to assess this damage as satellites. Sometimes we combine imagery from multiple satellites. This is a combination of sort of the visual, normal way that light is perceived from space, along with radar data that actually shows the change in ground level between the two, between before and after the explosion. And the sort of dark red fading off into yellow shows the changes in the level of ground. So it's showing basically everything that was destroyed in that impact zone. And that can be overlaid on top of the satellite data to show kind of a before and after, and really kind of come to terms with the disaster as it unfolded. There's a geographer named John Nelson who kind of pioneered a new method of looking at the lights on the black marble, and specifically between 2012 and 2016. And he created a map that specifically showed where lights had gotten dimmer and where lights had gotten brighter. And you can see just on this global view that there are plenty of both. But I'm going to zoom in here. This is Syria. As you can see in the sort of purplish color or magenta is where lights have gotten dimmer. And that sort of cyan blue color is where lights have gotten brighter. So if you look at Syria, you can see that Syria has gotten much, much dimmer across the entire country, but the areas around it have actually gotten brighter. And partly this is because of the refugee crisis and increased migration out of Syria into the neighboring countries, Turkey, Lebanon, Jordan, and Iraq. Similarly, you can see a migration probably happening here between Venezuela, a very economically depressed area, into areas like Colombia, which is actually recovering economically because they recovered from a civil war that they ended just a few years ago. And also you can see Puerto Rico getting much dimmer there. India is one of the most brightening parts of the world. You can still see some dimming areas, especially in rural areas. And this is one of the great migrations, probably the greatest migration that's ever happened in human history. And it's happening globally from rural areas to urban areas. And this is the great urbanization. So even as most of the lights in cities get brighter, the countryside actually gets dimmer. And today, of course, in 2020, we're looking at a pandemic globally. And this has not been invisible to the people studying the black marble. There was actually an article in July in the Atlantic that talked about this specifically. And right from the beginning, back in January and February, before people in this country were even really talking about the COVID-19 pandemic, this was already being tracked in the Hubei province in China. This brightest spot on this map is actually the city of Wuhan, which was the first place struck by the virus. And even just within a few days, you can see a real dramatic change. This is late January going into early February. And the specific change that you can see highlighted here, there's some kind of subtle differences in the way residential districts in Wuhan and other areas were lighting up versus commercial districts, which were darkening. But the most dramatic is actually the absence of all these highways. If you see all the sort of spidery highways and roads leading out of Wuhan, they all went completely dark within a few days. And this is after travel was basically strictly curtailed by the government. They probably even turned off the highway streetlights. Other parts of the world, including Spain, have actually turned off highway street lighting to discourage travel. But this sort of shows one of the first instances of reduction in transportation, as well as the way people changed in their urban habitation during that time. And much like John Nelson's model, this model has been used to sort of show between February and March, roughly about a month after the images I just showed, the lighting, the brightening and dimming in other parts of the world. Beijing has actually gotten rather brighter between February and March because after they had their initial lockdown, they increased their activity a little bit more than most parts of the world. Tehran, you can see the coast of the Caspian Sea got much dimmer, but as the city of Tehran brightened, probably because of economic activity, oil extraction, et cetera, on the Caspian Sea, was reduced, whereas people were basically staying at home in Tehran. And Delhi overall just really dimmed. There's a little bit of brightening in the center of the city, but for the most part, the rural areas and especially those highways and roads got much darker. Now, of course, this all probably seems like a lot of bleak stuff to look at right now. And I recognize that. And this year in particular, we've all been kind of face to face, if we watch the news and just living our lives. We're coming face to face with the pandemic on our own. And it might be kind of discouraging to look at these images and just see how extreme the impact of our species can be. We're a predatory species, we're a consumptive species, and we're not necessarily always a comprehending species. But we're also a social species, and I think one of the great things that these images give us is if you have an impulse of shock or empathy, I think that sort of shows the value of these images. And in fact, as I talked about with Puerto Rico, these images can also be used very proactively to combat these problems and to address them. And it's very easy to look at the budget going to space exploration or NASA, including the ISS itself, where they spend billions of dollars to maintain this space station up in orbit and launch humans up there at great expense. But I think the benefit we get from it can be measured in not just the scientific things that they're doing up in orbit, but also or the discoveries they make, looking out into the cosmos or to other planets, but what they can tell us about this planet. And of course, to say nothing about weather satellites and what they've taught us about climate change, but even just this one satellite taking pictures every so often at night can really show us a lot that we otherwise might find invisible. And so I think these are instruments of empathy and proactive change that we can look at. And as far as I think our own pandemic experience, for many of us, we've been living rather isolated from each other more than usual, and we've been struggling to connect with each other. And so I want to go back and bookend my main body of my talk with another astronaut. John Glenn was the first American to orbit the Earth in February of 1962 on the Friendship 7 capsule. And here you can see the orbital tracks. He made 3 orbits of the Earth. And one of those orbits, he passed close to Perth, Australia. And if you've ever seen a Mercury capsule up front, up close, it is astonishingly cramped. And during his mission, he was often out of radio contact with NASA. And so he was in a very confined space without a lot of social contact. Of course, it was only for a few hours, but you could arguably say that he was the most lonely human being in all of existence at that time, especially in a very cramped space, which I think a lot of us can probably identify with today during the pandemic. Very cramped quarters indeed. But in his orbit of February 20th, 1962, when he passed close to Perth, Australia, which is itself a rather large city on the west coast of Australia, but a very remote and isolated city from almost any other large city. And it's kind of unique for that. It's so far across the Australian outback from everywhere else that it's kind of isolated from everyone else. The city of Perth decided when the John Glenn flew over that they were going to light up every light that they could. They'd made it their civic mission to turn on all their house lights, to go out in the streets, wave flashlights and everything when John Glenn flew overhead. And he was rather touched by this experience, and he wrote about it later. And even today, this tradition kind of lives because Bob Behnken, who was one of the 2 space dads who went up on SpaceX's new Crew Dragon to the ISS this summer, he took a picture of Perth, Australia, and he says the land outside the city seems as dark as the Indian Ocean. And he also gave a shout out to Don Petit, who was an astronaut on the ISS several years ago, who kind of revolutionized these photos of the Earth from space. So I think we can sort of look in a more positive way at the lights, even if we maybe are frustrated with light pollution, and we're going to talk about that here in a moment with my 2 colleagues. But we also can look at the lights from our own Earth as the light we share with the cosmos and with each other. And if we look at these images, we can sort of connect with that. And especially when we sort of look through the eyes of the astronauts, we can find new ways to connect with each other, even if we're in isolated places, either in orbit or among each other on the ground. And as my man T.S. Eliot once said, we shall not cease from exploration, and the end of all our exploring will be to return to where we began and know the place for the first time. And this is an image of the Front Range, and there's where Boulder is. Some of you may be watching from Boulder. So, and with that, let's go back to my colleagues here, and we're going to talk a little bit about the other obnoxious side of the black marble, which is light pollution. And also open up for Q&A if anybody has any questions too.
All right, excellent talk, Will. So as an astronomer, I found it particularly illuminating, no pun intended. So great job. And so while we wait for some questions to pop into the chat, I was curious if you wouldn't mind discussing more of your initial motivation for providing this talk.
Yeah, my initial experience with these images actually came many years ago when I worked at a map store in Boulder called the Boulder Map Gallery. And one of the posters that we sold, it wasn't even really a map that we sold, but we sold this poster, and it was just the Earth at night. And there were a couple different versions of it. And people would always be struck by it, and they would ask us about it, like, oh, is this the Earth from space? And we'd always love to show them the Nile Delta and North and South Korea and some other places. And some of them even showed the fishing boats. So many years ago, I was having fun showing this image to people and sort of highlighting some of the cool things you can see. It's not just a pretty picture, or for some people, a disturbing picture, because it does really show how much light we're giving off. And it can be an eyesore for people, the light pollution, which we'll talk about here. But that's my first experience with it. And several years ago, I was involved in a group at Front Range Community College, and the International Affairs Club, if anybody's watching from there. And I gave a short presentation, and that ended up being a longer thing. And I continue to evolve it because there's so much spectacular imagery that's been coming out every day. There's new stuff, it seems like. So.
Awesome, awesome. Well, I look forward to talking about light pollution in a minute. We do have a few questions. So Sheena asks, how can they identify famines in these light images? Is such a thing possible?
Yeah, famines are trickier because it's not something that necessarily, people's access to food and nutrition is not necessarily visible from space, but it does correlate strongly with infrastructure for electrical grids. Of course, electricity is often vital for clean water, which also is a major factor in famines, and access to nutrition, not to mention irrigation, that sort of thing that produces food. So there's definitely a correlation. I don't know of any study that's been done that specifically highlights famines, but it's an indirect correlation, if you will. I think that there's evidence of that. That's a good question, though. That is one thing that Frank Borman talked about that's not visible from space. And of course, another way you can see it is with the lack of vegetation during the day. So the night images maybe are less, give less evidence of that, but I think satellite images do often show impacts on agriculture.
Awesome, awesome. And we also have a reference to the Bortle scale. Would you mind discussing the Bortle scale with the audience?
Yes, the Bortle scale is actually a measure of light pollution as experienced in a given spot on the Earth. So you can actually find websites that'll tell you what the estimated Bortle measurement is in your backyard, for instance, if you want to do some backyard astronomy. It's a scale of 1 to 9, basically ranging from the best night sky you can possibly imagine. Like Dinosaur National Monument in Northwest Colorado is one of the best places to get almost totally perfect night sky, where you can see things that you can see the Milky Way, but you can also see the dust cloud of the ecliptic, where the solar system kind of scatters light. You can even see the glow of ionized gas in the upper atmosphere that's not even the aurora, but like just sky glow from cosmic radiation. There's things that are actually visible if you get into the proper dark that you just wouldn't even believe. But if you're on the other end in an inner city situation, that's scale 9, where it's really bad. In my backyard, it's supposedly scale 5, right in the middle. I think it's more like 6 and especially 7 with all the smoke and everything today. But yeah, so in a suburban area, you might get a 5 or a 6. I forget what's the Summers Bosch Observatory in Boulder says. I think they say 7. I'm not sure, but they might say 6. But campus is not so bad because campus, they turn all the lights down to the ground, which is one of the best ways to mitigate light pollution. And that's a good civic thing to do, even if if you're in Perth, Australia, and you want to say hi to the astronaut flying overhead, you can shine your flashlight in the sky. But most of the time, I think it's more polite to shine your street lights and other lights down. John actually has some images that we were going to show of the transition between sodium lighting in streetlights and LED lighting, which is great for energy and the environment because it's much more energy efficient, but it gives off this much harsher blue light, which is very detrimental to human health, wildlife health, and it leaks into the sky much more. So you can see how these lights actually translate into space. So that's another change that also happens in color that we can see from the ISS, but not from the SWOMI satellite, is the sort of change from the orangish, yellowish lights of the city to a much more harsh blue, which is both good and bad because it's more energy efficient lighting, lower cost for cities, but at the same time is, it's one of the reasons we have apps on our phones that turn off the blue light and make it more red at night, is it kind of messes up our circadian rhythms, and that blue harsh LED lighting really does a number on it. So
For those who think astronomy is easy, I promise you there are many challenges. So we actually have another reference to the use of filters and how that can help with observations. And I know this is directly up your alley as a recent astrophotographer. So would you like to speak more on that?
yeah, I've been sharing with Jimmy and John I am very much an amateur astronomer. I'm sitting here virtually with two professionals, but like many others during the pandemic, I've gotten much more into astronomy in my backyard. And light pollution is a big issue, and you can actually find ways to mitigate it. Of course, you can try to get away from the city up into the mountains or further out into the eastern plains. But you can also buy relatively inexpensive little light pollution filters that will actually filter out the wavelengths of light that are produced by cities, and you can see more of like the hydrogen alpha emissions from emission nebulas and that sort of thing. And you can buy these on Amazon or High Point Scientific, other websites that are available that wherever you want to buy your astronomy equipment. Also Mile High Astronomy down in Lakewood. They're doing curbside pickup if anybody wants to pick up anything from them.
Great, great. And we had a question about
Light pollution is
Summersbosch Observatory. Definitely. So we had a question about light pollution filters at Summersbosch Observatory, and indeed we do have an array of many light filters. And once things normalize, we do have our open houses on Fridays, so you can see those firsthand. Great. So I'm curious about any other sort of light mitigation techniques that you think could be relevant. For our audience, for the city, what do you think would be some of the most beneficial steps that we could take collectively to address this problem?
Yeah, I mean, anything that you can do to reduce the amount of blue light you're giving off, and especially the amount of light that's pointing up or at a building. If you've driven between Longmont and Boulder, there's one particular building in Niwot that's lit up the whole side of it. I think they've darkened it quite a bit recently, so I think they've already taken steps. But it's that kind of lighting that's really focused up at a building where it bounces off and like scatters up into the sky that really is the worst. But even municipalities, any effort they can make to just put a little dark shell on top of the street lights on a highway will actually help direct that light downward. And also, if the streets are painted a darker color, of course, that has pros and cons too. That will also reflect less light from those lights. So there's all kinds of things that can be done to mitigate it. There's pros and cons to all of it. But if you want to do your part, get a warmer colored light outside your front porch, turn it off maybe when it's not necessary, and try to direct it downward are the best things to do.
Great, great. So I'd like to shift to talk about Starlink. So some of our viewers may not know what Starlink is, but how does that play a role in the life of an astronomer or someone who's just trying to appreciate the night sky?
Yeah, so I'm ironically wearing my SpaceX t-shirt. Starlink is a constellation of satellites planned to be thousands strong. They've already launched over 700. In fact, they were going to launch more today. They're actually putting it off till tomorrow because of weather issues. But they're launching about 60 of these satellites it seems like every week or two, they're launching another set of these satellites. And they've actually startled by people, especially in like the UK when they first go overhead, because there's this line of 60 satellites that look like UFOs, and so many UFO sightings have happened because of these launches. But the real concern for astronomers, and you guys can speak to this, especially as professional astronomers, because this is a very real concern, but it's also a concern for people just in their backyard. It's kind of cool to see them fly overhead. I actually enjoy seeing satellites in the ISS overhead. You can get apps that'll tell you when they'll go overhead. But if you're doing long exposures, like I've been recently trying to do in my telescope with a camera, you'll see this bright line go across, and it's, especially with all these Starlink satellites, they crisscross each other all over the place, and it creates this sort of like fence in front of your image. And you guys, that's the question I would ask you, is that something you've encountered in your career as a professional astronomer?
It certainly is a challenge for observational astronomy. And it's why the space-based observatories are such a vital asset. Is, we have to contend with wildfires, the light pollution, and now our very own space debris in a sense. So, the amount of factors are certainly adding up, and it is a true challenge at times, just to get, very authentic, long exposure images, particularly of nebulae and fainter objects that require very long exposure times. And there's an NPR study that 99% of American and European populations do not see a night sky that is uncontaminated by light pollution. So it's becoming a challenge, and the more factors make that more difficult. Excellent. So getting back to the chat real quick, there was a comment that potentially with the famines, you could use space-based satellites to measure the plant colors. And there's a reference to the Landsat satellites. So during your talk, did you see anything about studying vegetation from space?
Yeah, it's been since the 1970s they've done the Landsat program, and it's really been instrumental. And the Soviets were doing the same thing even as early as the 1970s. I studied a little bit the first Cuban cosmonaut, the first person of African heritage. Arnaldo Tamayo Mendez was the first Black person to fly into space, and he was flew for Cuba. And he actually, as part of his mission, was studying impacts on sugar plantations. So the interest in observing agriculture from space is many decades old, and Landsat is much better. The Suomi satellite is good during the day for that, but the night images just don't show it directly as much because you don't see the color at night. So, but that is very true.
I know during the squid boat segment, you mentioned you may think these are bioluminescent organisms. Are we actually able to image bioluminescence from animals on Earth?
I have yet to see an image.
Vegetation.
I have yet to see an image that captures that. Low light photography is really coming into its own from space. It's something that has kind of only really been revolutionized in the last decade or two. But I have yet to see any image that has been definitively called a bioluminescent signature. But it is certainly something, especially if you're in a dark plane. It's one of those things where I think the human eye, after it adjusts to darkness, can see it. It's like if you have a glow-in-the-dark watch, you might not be able to see the glow-in-the-dark until it's really dark, and until your eyes really adjust. And I think bioluminescent algae is one of those things, and it gets kicked up in like the wakes of ships and stuff like that. I think it brightens up under certain circumstances, but I think it's really dim compared to these fishing boat lights, which are really, really glaringly bright. That's my impression anyway, but I don't know for sure. If anybody has found a picture of bioluminescent anything, I would love to see it.
Awesome. So if there's any more questions, feel free to throw them in the chat. So I guess, Will, what do you think is the future? As technology gets more and more high tech, do you see sort of advances that can make our tracing of human activity, and vegetation? What do you think is the next step in terms of observing the black marble?
I mean, cameras keep getting better. I mean, that's one of the things they keep trying to sell us new smartphones is like you get a better camera every time. Every couple of years, you can get a camera that's got, better, and there's computer algorithms like Google has developed the night sight camera. And this actually can be applied. This type of technology can be applied to get better low light images from, even commercial digital cameras, which is what the astronauts on the ISS ultimately are using, they're high end, but commercially available Nikon cameras. And only in the last 10, 15 years have they really gotten cameras that can capture these images the way the human eye sees them. So that's just, of course, the qualitative, again, back to the qualitative versus quantitative. But the same thing is happening with scientific sensors. Better telescopes are being launched into space. That's the upside to the Starlink, is that it's supposed to fund SpaceX's launch vehicle development. The Starship will be able to launch huge space telescopes into orbit, potentially. That's that's part of the bargain, I guess, we might have with astronomy. SpaceX also, by the way, has been taking real efforts to darken the satellites so they don't reflect as much light. But as I'm sure you know, even a dark pixel covering up an image, it might fly in front of a star, and that even a totally black satellite will still disrupt scientific data. But sensors are getting better all the time. We're getting better, mirrors, optics technology. And I think computer processing of these images is getting especially good, so that we're able to get the signal out of the noise, if you will. I think that's the term. I think I've heard you
Awesome.
talk about that, Jimmy, with your research. So
Of course. Well, we could talk for hours. Before we wrap things up, is there anything else you'd like to share with the audience?
Clear skies. Hopefully these wildfires will go out, get outside and look out. Limit your time if it's bad air out there, but even a pair of binoculars, you can see amazing things out there, even if you're in a light polluted area. And I will say, I mean, we were just, before we started our talk, we were talking about Carl Sagan and Neil deGrasse Tyson. Both of them grew up in Brooklyn, and they both tell stories like almost the light pollution almost triggered their interest in astronomy and astrophysics. And the visit to Planetarium, especially for Neil deGrasse Tyson, he went to the Hayden Planetarium, and that was like his mind-blowing experience. And now he shares that mind-blowing perspective with all the rest of us. So even being deprived of something could arguably be a good thing. But if you're here in Colorado, we have great dark skies most of the places. Get out there and look, because it's gorgeous, and it's a great activity during the pandemic.
Awesome. Well, great talk today, Will. For our viewers, please be sure to tune in. Our next talk will be next month. It'll feature Chris Gilly, and we'll be talking about the vastness of space. Thank you, everyone, and we'll see you next time.
Thank you so much, Jimmy. And John.
Thank you.